when we talk about the aim of a design, all right, or of a build, that aim is whatever your design has to be able to accomplish. So by the end of the time that you are allotted, once you've had a chance to plan it and construct it and fix it, you're going to test your design, and it's going to have to be able to do something, okay, for whatever reason, like the purpose of your design and what it has to accomplish. So that will go in your aim section. All right, now unlike the scientific method, the design process, the aim or the problem statement, if you will, does not have to be a question, because you're not trying to answer a question with your results. Okay? Now, once you establish, and all of the stuff that we're going to write on this front page here, this first page, this all has to get done really before you start building. Okay? So the second thing you do, once you know what your machine has to accomplish, you're then going to look at something called the design plan. Next thing we've got to look at is our design plan. And the design plan always looks at two different aspects. First off, your design criteria. What is it that the prototype itself must accomplish? Okay, in the case of your gear car that you built, the gear car had to be able to travel a distance of 3 meters in 3 seconds. So that was your design criteria. If somebody tells you that your prototype has to be used, 5 or 6 times without it falling apart, like we did with your airplanes, well, that is a design criteria. Okay? These are things that the prototype must be able to accomplish. So the second aspect of the design plan is listing your constraints. So most often, the most common types of constraints involve only having access to certain materials for your build, only having a certain amount of time to complete your build. Okay, maybe you have to work in pairs, maybe you have to work solo, so manpower, all right? So things that you don't necessarily have control over, but that you have to be able to work around. Okay, so those are your limitations. Now, once we've established what our design plan is, now we can actually get to the drawing board. Okay, we can actually start putting down some ideas and then really evaluating the various ideas we have. And when we talk about putting down some ideas, I'm emphasizing the S there, because you always need to establish more than one actual idea. You can't just try and build the first thing that pops in your head. Some of you have a hard time with that. Some of you get stuck on one idea and you have a hard time changing your minds, right? And that's part of your charm. But you really should always, in the brainstorming section, okay, so brainstorming. Now, brainstorming with just one person is kind of boring, because you are gonna have one idea that you like more than the others. But in actually thinking about what it is that you have to do, maybe you will actually look at a situation and you might come up with, after you've started thinking about it, you might actually come up with something else that you like. And the interesting thing about brainstorming is that you can combine different aspects of different ideas to make a whole new one. Okay, so when you brainstorm, you're going to need at least 2 sketches. So, and we're not talking about just really like quickly, messily drawn things. We're talking about actually sitting down and putting some effort into, thinking about the dimensions, the measurements, the materials you're going to use. So in addition to your drawings, okay, so your drawings appear here, perhaps you label your drawings with different materials, and maybe you establish what the measurements are going to be, or you've got your drawing and you might have a little list of information next to it. So brainstorming involves drawing ideas up. Ideas and simple explanations. So if I look at your brainstorming, I should be able to say, okay, I see where she's going with this. I see what she wants to try and do. Okay, so drawing simple ideas and explaining those simple ideas. And at the end of your brainstorming, you're essentially going to rank your actual ideas. You're going to choose one of them and say why you're going with that one. This is why you always have to have at least 2 ideas. Because if you only have one, you can't really rank that. And this becomes very important when you're working in a group and you're brainstorming ideas in a group. Okay, this is where not disregarding anyone's ideas is important. But when it's just you still have to have at least 2 potential options. Okay? The question that was just asked is, will we get the idea beforehand and have a chance to go home and look things up? And unfortunately in science, no, you don't get that chance because science measures 2 different types or ways of thinking. Okay? It measures the theory and the knowledge, and that's what you have time to prepare and practice. Those are written tests and things like that. But it also measures how you are on your feet. If I give you a situation and you understand the design process, you should be able to incorporate with certain prompts an actual design. You should be able to do that because we've been practicing it all year.
And we don't have an ed memoir, right?
No ed memoir. You're going to get whatever you need. Okay? Once all of this is done, once you've identified what it is your design has to accomplish, you've listed any constraints, you've set out what your aim or your goal is, and you've ranked some ideas, now you're ready to actually build. Okay? Up until this point, you have not touched anything yet. Once you get through here, this is where it gets interesting. Okay, and we fall into that loop, that continuous idea of the iterative process. So the iterative process is that section in your design where you list any changes that you've made or improvements that you've made to your design. Because the first thing you are going to do is you've planned in the brainstorming. Right? So there was your initial prototype idea. You're going to build your initial prototype idea and then you're going to go test it. Okay? And when you actually test it, it's probably not going to work. Hypothetically, it doesn't work. Well, the great thing about the iterative process is this first one, okay, this first idea here leads into the second one. This second one leads into the third one right here. And this third one, if you test it and you don't like it, it goes right back up to the top. And it continues this cycle until one of 2 things happen. You accomplish your task or you run out of time. Okay? So in the iterative process, most often you will see something like iterative process. List all the improvements that you've made to your prototype. So in this case, if you had to build your gear car, you set up a gear train, you plugged in your car, and it didn't even move. Okay, it didn't even look like the motor was working. So you went back to the drawing board and maybe you added those bushings. Well, you would make note, bushings were added to the car at this location in order to allow it to turn better. Okay? You might then go test it again. And maybe it doesn't work. Even if potential improvements don't work, you still list them. Okay? And through this is not a procedure. You do not state, first the car was taken, then a gear ratio was made, then it was plugged in, then we tested it, then we did this, then we did this. That is not what the iterative process is. The iterative process is supposed to basically follow your thought process on how you improved or changed your design. Because your final design, the one that you end up with, will not be the same as your initial prototype. It will be different. It will be changed, improved, added upon. You might even decide, oh my God, I've added so many things, I've got to start over. And maybe you'll do that. Okay, but this part here, this is where this is going to be collectively, the iterative process is going to be collectively worth the most marks. Okay, because it is a really important really important section to see your thought process, to see how you've actually gotten to any problem and how you've tried to overcome it. Because remember, when you're doing a lab or a design, you're thinking on your feet. So if you hit this obstacle, you don't just say, okay, well, I'm done. I don't know how to fix this. You say, okay, well, all right, well, what do I have to do to try and make this work? And you're going to try something, and maybe it'll work and maybe it won't. Then you're going to try something else. So even if your build does not work, even if it's a complete disaster, and every one of these tries that you've listed here, try one, this was improved. Tested, it didn't work, so we modified it to this. Tested, it didn't work, and this, and this, and this, and that. And at the end of it, if it still does not work, that's okay. You will get full marks for this. When you're done your iterative process, you have to actually basically look at your results and come up with whether or not you successfully accomplished your design criteria. Because if we remember, the design criteria is the objectives that the prototype had to accomplish. Okay, so your gear car had to drive 3 meters in 3 seconds. Did it accomplish this? This is where you will state whether it did or not. So in your conclusion, we've got 2 different aspects here. Did it basically accomplish the design criteria that you set out? You have to explain. You can't just say, the design criteria were accomplished. You have to say they were accomplished because the car was able to travel this distance in this amount of time, and the gear train did not fall off the car. Like it basically survived. Okay? And then the last part, super important part, is listing improvements to your design. So when we talk about listing improvements to the design, okay, there is no such thing as saying, I would not make any improvements to my design. It is amazing. Okay, that might be the case. It might accomplish its task. But if that was the case, we'd still be driving Model T Fords. The one where you had to crank the engine. Okay, to sit there and crank the engine, or the one that had the candles for the actual headlights. We would never be trying to improve technology. So even if your technological object improves, you could come up with a minimum of 2 improvements. Okay, so minimum of 2 improvements. Okay? Now, all of this is worth a big chunk of marks. We just went through the entire design process. All of this is worth a big chunk of marks. And the last little bit of marks that you're going to get is you are going to get a rubric. Okay, so in that little rubric, you are going to see that there's probably 3 or 4 lines, each worth 5 marks. And then what's going to happen, and it's going to tell you, your design was able to do this. This, really good, really good. Not so great, better, really good, excellent. So it's going to give you different criteria that your design will be evaluated on. And whatever mark that is out of, let's say it's out of 20 marks, even 25, even 30 marks, it's going to be brought down to only be worth 5% or 5 marks of the total actual booklet. And the total actual booklet is maybe 35 marks. So the vast majority of the marks come from the actual design process, the writing part. Which is why myself or whoever is in the room with you will stop you building at one point. They will say, all right, it's time to put down what you're building, even if you're not done, and go work on your booklet. Make sure your booklet is done, because that's what's worth the most marks. So even if your prototype sucks a big bag of lemons and does not even move, does not even accomplish anything, you can still get a lot of marks out of this.